Hi everyone, Miss Barber here with Lesson 1.7 in Algebra 2 function notation. So in Lesson 1.6, we learned about what a function was. So remember, functions have inputs and outputs. And in order for something to be a function, for every input, there can only be one output, meaning you can't repeat any of your inputs or your x's or anything in your domain. You can only have one of them. Function notation will always be written with this f of x, or it might be g of x or something like this, representing the output value. Well, your output value, typically how we used to write it prior to today, is just a y. So whatever you put in, that goes in for x, and that will give you an answer, which we used to call y, but now we'll call it f of x. Whatever in parentheses here, so with this x, will be what you're substituting in on the other side. So for here, f of 1 means we're putting an input of 1 in. Well, if I put 1 in for x, I do 5 times 1, which is 5, plus 3. So f of 1, which we used to call y, is going to be 8. That's my output. So my input is 1, my output will be 8. So all you're doing is substituting in what you see in parentheses in for x for each problem. So number 1, they want us, given our function, to evaluate for f of 1, f of 0, and f of 3 halves. So for f of negative 1, this time it's g, so I'm going to do g of negative 1. I'm just substituting in negative 1 in for x. I always like to do parentheses like this for where my variable is. So here's my variable x. I'm putting parentheses in there. So I know I'm going to substitute in negative 1. Well, simplifying negative 4 times negative 1 plus 2, you're going to get your answer to be 6. And we can do the exact same thing for my others. So g of 0, so substituting in 0. Again, I'm going to do negative 4 parentheses plus 2, and I'm going to substitute in 0. When you simplify that, you get 2. And then my last one, I'm going to do g of 3 halves. If you don't like 3 halves, please remember 3 halves is 1.5. So if you prefer to put the 1.5 in if you're using your calculator, you're going to get the same thing. So it's going to be negative 4. And again, I'm substituting in 1.5 or 3 halves in for x plus 2. When I do that, I get negative 4 as my answer. So that's all you're doing. You're just substituting it in. I'm going to do number 3, and then you should pause the video to try numbers 2 and 4 on your own. So for number 3, we're going to go through the same process. This 4 is not meant to be there. Sorry, that's like the number 4 over there. So you can ignore this number 4. It's not supposed to be there. So let's start. F of negative 1. So again, I am just substituting in negative 1 wherever I see an x. So it's going to be 3 parentheses squared plus, you don't have to write the second one, but we will, and substitute in negative 1. Negative 1 squared is positive 1 times 3 would be 3, plus negative 1 would be 2. So that would be your first answer. Second one, f of 0. Again, we're just substituting in 0. 3 to the 0 squared plus 0. Well, you're going to get 0 when you put 0 in for everything. And then lastly, f of 3 halves, or 1.5, whichever one you like better. 3 to the 3 halves squared plus 3 halves. Simplifying this out, probably easiest just to use a calculator. You're going to get 8 1/4, which is 8.25. So that's just substituting in your input values to get an output value. So please pause the video and try numbers 2 and 4 on your own, and then check your answer against the key. The output function f of x is called the dependent variable because it depends on the input. So the input x is called the independent. So we have lots of new names here. So remember your variable. So in this case, they use t. That's your independent variable. So d of t is your dependent. Typically, we probably would have called tx and d of ty. So on your graph here, they labeled the x-axis t, but you could also label it the x. It's the independent variable. You could also call it the input, and it's also part of your domain. So lots of words to mean the same thing. So your d of t, again, we may have called this y prior. You could also call it your output. Your y-axis is your output, or the range. So it's taking what we already know about graphs and equations and putting it in terms of functions. So graph each function, then evaluate f of -2 and f of 0. So we're going to graph this. You can use your graphing calculator, you can make a table, however you want to do it. Well, I know that when I substitute 0 in, 0 squared minus 4 is -4. If I substitute 1 in, I'm going to get 1 squared minus 4, which is -3. And because I know this is a quadratic equation, I know that it's going to be symmetric. But if you would like to make a table, that might be best for you. X and then f of x. And we'll do -2, -1, 0, 1, 2. -2 squared, substituting in -2 here, you're going to get +4, minus 4 is 0. -1 we already said was -3. 0 was -4. 1 is going to be -3 when you substitute it in. 2 squared is 4 minus 4 will give you 0. So this is called a parabola. You might have remembered it. This is what it looks like. So it wants us to evaluate it as f of -2. So this is when saying when x is -2, what is my y? So f of -2, when x is -2, what is my y? Well, when x is -2, this is my point here at -2. Well, when f is -2, my f of x is 0. You can see from our table as well. So my f of x would be 0. When f of 0, so again, when x is 0, what is my y? Well, here's 0. My y is -4. You can see that from my table as well. So f of 0 is -4. So that's how you would do number 5. Number 6, because we haven't gone over graphing yet, I'll help you graph it, but then you're on your own for finding f of -2 and f of 0. So you might have recalled when graphing a linear equation, so this is like y equals mx plus b. You always start with your b. Well, my b is 1 on the y-axis, so that's my y-intercept. So I'm going to graph +1. Then my slope is -3/2. So I can either go down 3 and right 2. So 1, 2, 3, right 2 to give me a graphing point. I can also go up 3, left 2 from my y-intercept. So 1, 2, 3, 1, 2. And then that's my line that I can connect the best I can. So that's my line, and you should now be able to find f of -2 and f of 0 from this line. So pause the video, try those, and then check your answer. Last thing are these 2-word problems. First one, on one day the value of a 1s US dollar was equivalent to 77 euro. On the same day, $1 US was equivalent to $1.24 Canadian. Write a function to represent the value of the Canadian dollar in euros. So we want to make a function where our input is Canadian dollars and my output is euros. Okay, what is the function if we put in 5? So again, we want our input to be Canadian, our output to be euros. So let's think about this. We'll call this f of c. C stands for Canadian. Well, for my Canadian dollars, they said 1 US dollar was equivalent to $1.24 Canadian. So let's say I gave you $1.24 Canadian. I'll call that C. If I divide it by $1.24, I would get 1 US dollar. So the $1.24 Canadian, which is C, if I divide it by $1.24, you would get 1. So that's my dollar US. So this fraction so far basically just represents $1 US if I put in $1.24 for Canadian. If you put in $5 here for Canadian divided by 124, it would tell you what that amount is in American. Well, I want to know what the dollar is in euro. Well, euro represents 0.77, so $1 US is 0.77 euro. So if I take my original little fraction here and multiply it by 0.77, that would give me how much it is in euros. And again, the best number to check, because we know that $1.24 Canadian is $1 US, which is a 0.77 euro. So if you were to put in $1.24 for C, you should get 0.77 as your output, which you do. So this is the correct function. Now we need to figure out what f of 5 is. So when we have $5 Canadian, so we're substituting 5 in for C, how much is that in euros? And that's about $3.10 euro. And you probably shouldn't use the dollar sign because it's euros. My bad. So it's about 310 euros, or euro. I don't know what the proper way to say it is. Something like that. Last one, PC Haven sells computers at a 15% discount on the original price plus a $200 rebate. So a rebate means you get that money back. Write a function that represents the final price of a computer at PC Haven. What is the value of the function with an input of $2,500 and what does it represent? So we're talking about the price of something. So I'm going to say f of p because that's going to stand for price. When you are selling something at a 15% discount, you have to think to yourself, how much are you actually paying? Well, if you're getting a 15% discount, you're actually paying 85% of the total. Well, 85% of the total is 0.85. So it is going to be 0.85 of whatever the original price was, P. So that'll tell you what the 15% discount is. But then you're also getting a $200 rebate, meaning you don't have to pay $200. So you can subtract that off your total price. So this will be your final equation, function. The first part, 0.85 times P, is what 85% of it costs after the 15% discount, minus 200 is that $200 rebate you get. So let's now substitute 2,500 in. So I'm going to get 0.85 times 2,500 minus 200. When you do that, you get 1,925. Meaning, something that used to cost 2,500 now costs 1,925. So you got a little over 500. You actually got $575 off. That's it for lesson 1.7, function notation. Please make sure that you're trying the ones on your own and checking